Part B, we are having magnesium oxide. We are having magnesium oxide. Magnesium oxide, which is Mg. Oh, that is magnesium oxide. So within magnesium oxide, we have our magnesium. We have our magnesium. Magnesium, which is Mg. Magnesium, according to the periodic table, magnesium is element 12 with electronic configuration 2 to 8 to 2. 2 to 8 to 2. And then oxygen, which is it's element 6 with electronic configuration 2. Sorry, oxygen is element 8 with electronic configuration 2 to 6. Electronic configuration 2 to 6. So we do the same. We are going to start by drawing the atomic structure. We're going to start by drawing the atomic structure of magnesium. The first shell has 2 electrons. Then the second shell has 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. Last shell has 2 electrons. That is magnesium. Oxygen, we shall have something of this form. Last shell has 1, 2, 3, 4, 5, 6. We're having both atomic structures, one for magnesium, another one for oxygen. We do the same thing during formation of an ionic bond. During formation of an ionic bond, a metal loses electrons to a non-metal. We lose electrons which are strictly unpaired. When you look at the atomic structure of magnesium is our metal, so it will lose this electron to that, and it will also lose this to that. So you are seeing that we are transferring unpaired electrons to where there is unpaired electron on the atomic structure of oxygen. We are transferring this to where there is unpaired electron of oxygen. So that is how we transfer those electrons from it being unpaired to where there is another unpaired electron, such that we come up with paired electrons. So when both of them combine, we shall have this. We shall have this as our new atomic structure of magnesium. We shall have this as our new atomic structure of magnesium. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. So this is my new magnesium. So here magnesium lost 2 electrons, this one and that one. So we shall have a 2+. Why 2+? When metals lose electrons, we form positively charged ions. And this one has lost 2 electrons, so that's why we have 2+. Positively charged ions, but with a charge of +2, yes. Then oxygen, we shall come up with this as our new oxygen. We shall have this as our new oxygen. 1, 2, 3, 4, 5, 6, 7, 8. With a 2 minus. It has gained 2 electrons. So the whole of this is what we are calling magnesium oxide. So I have drawn both of them when they are close to each other because there is a force of attraction binding them. This is 2 minus 2 minus. Then we are going to look at method 2. There is a second approach of how to summarize this. So if you don't take that path, let us see method 2. Method 2. Method 2. Method 2. We are having our magnesium. We are having our magnesium. Magnesium. We are having our magnesium, which is Mg. Our magnesium, which is Mg, with the same electronic configuration. Since it is element 12 with EC22H22. So during bonding, electrons in the outermost electron shells are the ones which participate in bonding. Now, are you seeing here electrons which are in the outermost shell alone? These electrons in the outermost shell. You are seeing that these ones which are inside, for them, they don't participate in bonding. Only electrons on the outermost shell are the ones which bond, and when they are unpaired, So I can summarize this electronic structure of magnesium by having this Mg 1, 2, because I only need outermost electrons, or electrons in the outermost shell, so that's why I'm having this. Then also oxygen, which is O with electronic configuration, element 8, electronic configuration 2 to 6. So I can also summarize oxygen, the atomic structure of oxygen, by coming up with something of this sort. Oxygen. So this is capital O. Then outermost shell, I'm having outermost shell. I'm only representing outermost electron shells. So 1, 2, 3, 4, 5, 6. So you are seeing that the outermost electron shell of oxygen has 6 electrons, and the one for magnesium has 2 electrons. So we transfer electrons from a metal to a non-metal. Transfer this one to that, and also this one to that. So when we do that, we shall come up with this. Now this will become Mg 2 plus this one, and then this one for oxygen, for it will look like this. It will look like this. That is capital O. And you're having 1, 2, 3, 4, 5, 6, 7, 8. We have added 1 electron here and another one there. So we shall come up with 2 minus. So you can also take that approach. So you take any approach which you think is easy according to you. So in our next session, we are going to look at covalent bonding. So basically that is ionic bonding.